Our Dev Express technical evangelist, so kind to have pitched in at the last minute to do this presentation for us. And apparently what he's got planned is he's going to just sit down and start writing some code. And anybody's welcome to ask questions or pitch in, whatever they want to do. And I guess we can take it from there.
Cool. So I don't have any slides because slides are stupid, right? We're all programmers of sorts. Slides are for like the business people, right? And they want to see slides. But programmers, we want to see code. And today I'm going to talk about the functional aspects of C#. And I'm going to start with C# 1.0, and we're going to go through a couple of things. The thing about this session is that it's designed to be very interactive, and so if you see something that doesn't look right, or you see something that you don't understand, it's not because you're not smart, it's because I'm not explaining it well. And so please understand that it's my responsibility to help you understand something, and if I'm not explaining it right, it's my fault. That's the first thing. The third thing that I want to say is that I'm going to be doing things with code that you should not do regularly, right? This is not stuff you should be writing, but it's stuff that when I do it, you're going to be like, oh, okay. Most of this stuff you probably already know. Maybe there'll be some cracks filled in, or maybe you'll just know it all. But I think it's a good review of thinking functionally in C#. I'll tell you that the first time I started really thinking in a functional way, I was in a master's class on functional programming, and the bachelor's degree was kind of like, here, jump through hoops, right? Remember when it was just here, jump. But when I went to the master's classes, it was a little bit different because when we showed up, there was 15 of us. It was a functional programming class. The teacher said, all right, everybody pick a functional language. Like, okay, and we picked one. He's like, hey, what do you guys want to do for next week? And so everyone was like, hey, why don't we do it? And so he said, why don't we do this? Let's make a Sudoku solver, and you do it, implement it all on your own in the language you chose, and come back next week, and we'll just talk about how we did it. And there was no grade, right? We were all going to get an A. We all knew this, but the amount of effort that we all put into these things was significant. And I started to learn things about programming that I never thought were possible, and it changed the way I've written code ever since. You guys have probably seen, for example, lambda expressions. You've seen link. You've seen IEnumerable everywhere. These come from the functional sort of thinking of writing code, and we're just gonna play around with it a little bit today. So, any questions or comments? Anyone write in a functional language?
I've done like 3 hours of Lisp.
Oh, okay. Okay, Lisp, yeah. They have a lot of parentheses, if I remember right.
Yeah.
So I'm going to use the Visual Studio 11 beta so that if there's any... Maybe I should have started Visual Studio first, yeah? Is that like your routine? I never turn my machine off because I don't want it to... Okay. So here we go. My code is usually pretty big, and so everyone should be able to see here. Okay. So, can this chair go down?
Yeah, it should be on the...
Right here. And if not, you can have one of these snazzier chairs.
Nice. All right. So we got this. Everyone is familiar with this. This is just the regular thing. And so the first thing we're talking about is delegates. How many of you are familiar with delegates? You've heard of them. We've played with them. The first thing I learned in functional programming is that functions are a thing too, right? And that's important, right? And in other languages like JavaScript, you can say var x equals function, boom, and then put stuff in there. That's certainly the case also in F#. But when we started in C# 1.0, we had these things called delegates. So we have a delegate, and the thing about functions is functions are different than just regular types, right? Because functions have to have a return type, and they have to have a set of parameters. So we're going to say delegate void do something, and we're going to say a string 1. So this is just a type now, right? So I can say int I equals 0, and that's okay, right? I can make a function over here. So static void 1, and we're going to say string 2. And we're going to say console.writeLine, and we're going to say 2. Okay, we got it. So notice that this thing looks like this thing. You can see that. So when I say do something, s equals 1, that should be okay, right? Let's ask the compiler for permission. See that? It's okay with it. So now, this is the thing that was confusing to me when I was first learning functional programming, is that this I'm okay with, right? This is kind of scary. But it really shouldn't be, right? It's a thing. Functions are a thing too. So now, with this thing, you can do all sorts of other things. Like, for example, what can you do with an integer? Well, you can add it to another integer. You can subtract it from another integer. You can pass it around as a parameter. Right? You can do all sorts of things. So let me show you, there's two aspects of a function that I think are very important. The first one is that functions are things. So you could say do something y equals s, right? That should work. Let's ask the compiler. Yeah, it's okay with that. So notice that we can do this. But the other cool thing that we can do is we can execute it. Right? That's the thing that's a little bit different. Now, when we say y and we put the parentheses, we're saying, okay, now you're not acting like a thing, you're acting like a function. So we're going to pass in something. We're going to say Seth, and then we're going to run it. Okay, so let me run that, and the thing that you're going to expect to see, obviously, is that what's going to happen. Yeah, it writes out Seth really fast because I forgot to do the. That's right, console.read key. Man, I shouldn't have gone to McDonald's and gotten the chicken sandwich. I'm really sorry. So there you go. And if I do s of Seth, oops, s of Bob, notice that we're actually calling the same thing twice, right? So there that is. So this is okay, right? But here's the crazy thing that some of us, maybe might have a problem with. I can do something like this, right? And I can pass in s, and I can pass in 1. But then I have to do something crazy, like I have to say this. Uh-oh. Let's see what's going on here. The best overloaded match for I don't see the problem. You guys see a problem? Here, let me just be even more clear, right? Because remember we said we could add it. That's the real function, but for some reason it's not working. Let me just do this.
What is 1?
Oh, that's right. 1 is this right here. It's a thing. And I have to cast it as a delegate. But it has to be a special type of delegate. So let's see. Where's my problem here? So let me cast it as a do something. There you go. So the compiler is okay with this, right? But this looks kind of weird, right? It turns out that this particular call is the delegate.combine. I don't know why it didn't let me do it, because you can pass in a series of delegates, and I can pass in 1, and I can pass in 1, and you know what? Let me do a 2. Let me just do a copy here, and let me call this 2, and let me do this 2 plus. And I'm going to do this here. This is going to be 1 plus, right? Okay. So notice that there are 2 different functions.
It's a little confusing in the functions that you're using the names of the functions as method
Oh,
parameters.
should I use a different parameter?
Yeah.
Let me do x here.
Okay.
Is that okay?
Yeah.
Good. Okay, we're good.
But you need to change line 27 and 32.
Man, precise.
Thanks for turning on line numbers. It helps a lot.
Oh, thanks. Yeah, I usually have that on just because. By the way, it's not going to compile because I have to do this. So delegate.combine, you could do 1 and 2. This should do something. So var, let's call it D. Boom. But for some reason, I don't know why it doesn't like that. Maybe you have to cast it to delegate. I don't know. But in the end, what it's really doing is it's doing this right here. It's adding these 2 things together. So I could say 2 and 1, Wait, did I call it the right thing? Static void string 2, 1, 1 plus 2. I keep naming everything like the same thing, which is causing confusion. So let's build it again and let's see. Group 1 y equals 2 plus 1. I don't know why this isn't working. Maybe it's a .NET 4.5 thing, but there you go. I did it. So what do you think this does?
Throws a cast exception.
Let's try it. I don't think so. Let's look at what's going on now. What does it mean to add two delegates together? Here, I'll zoom in here so we can get it.
You're chaining them so they get executed on there.
That's right. In fact, the thing that I find most surprising is that we do this all the time. But we don't think we take it as like a weirdness. When do we do this all the time?
Chaining them together like that?
Mm-hmm. Do we do it at all normally, or is this like the weirdest thing I've just done? I don't know why I have to cast them. That
We
makes me
do it
mad.
with events.
That's right. Have you ever said click plus equals, and then you put a function? Didn't you think that was kind of weird? Yeah, well, what you're doing is on these events, it's just a delegate. An event is a special kind of delegate, right? That only can be executed inside of the class that is declared, among other things. But what you're doing is these things are called multicast delegates. They're single cast delegates, but they're all really multicast delegates. And what's happening is when you add a function to that delegate, you're saying, here's the invocation list. So let's actually step through this. And no, I don't use Visual Studio 11. I thought it would be cool if we did it. Maybe it wasn't a good idea. So I'll hit F10. Let's take a look at do something Y. So let's do a quick watch here. Look at this thing. Notice that there is this cool little thing called the invocation list. And what we've done is we've taken two methods and we put it into one method. You can see that in the invocation list, when I hit the plus, we have two different methods. And you can see the base in there. Let's see if it'll actually give us the name. No, it's not giving us the name. Yeah, there it is. That's the method. And then as we go down to this other one, you can see that this base one, right, has the 1 in it. Oh, it does tell. It says right there. What am I saying? So notice that the two methods that we're going to execute are 2 and 1. And notice that the order is important as well. So let's zoom out of here, and let's hit the stop. And let's say y plus equals 1. Let's take s out. Notice that this is still okay. In fact, I could have said a y, do something y equals 2. Jeez. Sorry, do something y, because I don't like how it's really big. And then I could have said y plus equals 2. Right, and then I could say y plus equals 1, and then I could say y plus equals 2, and then all sorts of weirdness happen, right? So the invocation list then is going to be 4, and it's going to execute each one of those methods in that order 1, 2, 1, 2. So let's see about that. See that? And so when you're working with methods, the reason why anyone that attaches to that event by pointing it to a function, every one of those is going to get called in the order that they've been put in. And that's how events are working. It's a functional concept, right? The thing that I never liked about Java is it didn't have this. Yeah, it had some. You had to do some stupid pattern. I don't remember to do events. Maybe that's not the case anymore, but Java doesn't change as fast as C#. So that's how that works. So Let me ask about this. What if I do this? Oh, let me. What if I do that?
So you go through the invocation list in reverse order and delete the last instance of one.
See, I didn't know that's what it did.
I think.
But we know it's taking one of them out. You can see that. Clearly it's taking one of them out.
Might be the first one.
So now let's do this. Now what is it going to do? It's going to barf. Is it?
No,
Why not?
I don't know.
Right? It's just going to take the ones out. But if you take another one, it's be like, I don't got one. It's like a negative delegate. No, I'm not going to say anything close to that. That's just crazy. But
It doesn't complain?
no. Why would? But if you notice it, it's like, I don't know. I mean, we don't complain when we multiply any number times 0, right? We still have 0. Maybe this is how they decided. Maybe there's some discrete math reason for this, right? When you're taking away a particular function, if it's not there, you just do nothing. You know, it's like something crazy, like me minus good looks. I'm still the same guy, right? Probably haven't taken away a lot, but still. And so this is the one of the things that I think is probably the coolest. Did you know that you can multiply them? No, I'm just kidding. I don't know. Let me try. 1 equals 1 times 2. That's right. That's right. But notice that this is the thing. These things have a type, right? In this method. It has an invocation list and all that. You guys probably already knew this, but you probably never did stuff like this because it seems unnatural. Right? To do what it's calling in the background is a delegate dot combine, and like that. And so here's the other thing I think most people will have a hard time with too. We're going to make a new method, and we're going to call it super do something, and we're going to get us its parameter a do something. Hold on, I think I pushed too many buttons. Do something do something x, and a do something y. So here is, we don't even need this thing, so I'm just going to kill it. So here is a function that takes functions. So let's do something. So we're going to say do something in the method. I'm sorry, we need to do x in method x. And then we're going to call y. And so now what we can do is we can, let me delete this. Someone asked me, because I did this talk once, and they're like, hey, can you give me the code? I'm like, I erased it all as I kept going, so. All right. So super do something, we're going to pass in 1 and 2. Let's ask the compiler for permission. Then it's okay with that, you see that? So what does this mean? Now again, remember, the third rule that I said is don't ever write code. It's just not a good idea. What is it that this is going to do? And let's go down and see why. I'm calling this function, and I'm passing in 2 functions. I'm passing in the first function x, and x is going to say 1 in method x, right? The second one is going to say y, and then in method that's new 2. So that's what you're seeing, right? 1 in method x, 2. Let me show you. Let's do the following. Let's step through it, and you can see the coolness of what this is actually doing. Does anyone like this IDE? Doesn't it seem kind of? All right.
Where's all my gradients?
Ah! Here, let me kill this here. So I'm going to do F11 to step into it. Watch what happens. F11, boom! Right? Notice that it automatically goes to the appropriate method, then it goes back, and it says, okay, we're going to go here. Now we're going to go here. We're done here. We're done here. We're ready to read the key. Holy cow, I've never seen this in teletrace. Can we rewind?
Yeah, sort of.
Oh, man, that's cool.
It doesn't record the state of all of your variables, and unfortunately, it's not in Professional Edition. You need like Premium or Ultimate.
They want our $10,000.
Yeah.
So I'll hit F5, and you'll see that the same thing is happening. Right? So it's okay to pass functions in this stuff. So the thing about this particular approach is that it's really cool. However, it's a little verbose, right? Because we have to first declare the type. It's kind of like a class, but it's not, right? It's just declaring. It's like a one-function class type, right? And maybe you can call it that. I don't know if I should, but so it's a one-function class type, right? So you can have do somethings everywhere if you want. Notice that you cannot have a do something if it's like if this is an int, right? It's gonna be angry. It's gonna say, wait a minute, hold on. That's supposed to be. You can't do it. There's some problem. It knows. So it's type safe. There's no weirdness going on. There's no it's not dynamic. It's very not dynamic, and that's important. So that's how that works. And so what happens is because these things were so cumbersome. Instead of there were certain kinds of delegates that were being used over and over again, right? And so what they did is they said, well, let's just make them. So we have this thing that you know about called an action of t, right? And an action of t is a function that takes no parameters, does something. It returns. I'm sorry. It takes things, but it doesn't return anything. Sorry, I got that backwards. So an action of t takes a bunch of things and does something, right? So for example, this here, notice it doesn't return anything. So it would be a perfect action. In fact, I could say action of string A equals 1. Because this happens to be a built-in delegate. You can see right there. They just built it into the core library because we know we use that. And you know what? They also said, you know what? You might need an action of t that takes 2 methods, or 3 or 4 or 5, or whoops, we're out of luck if you need more than 16. Right? So you can there's already built-in delegate types for anything that takes in up to 16 t's. And now a t, as you already probably know, it stands for really any type. You just have to tell. It's a generic kind of a thing. Okay, so that's how that works. But the other thing is that they thought, it's cumbersome. Maybe we don't want to declare it like that. So they had inline delegates in you recall in C#2. So I can say string of s, and then I can say CWS. And so now we have these things. So now instead of having to declare the method externally, you can declare it inline anonymously. It's an anonymous method declaration. Right? You just put it in. And so they said, this is cool too. Right? This is C#2. I think it was 2. Yeah, it was 2. That they allowed you to do this. So notice that the progression is getting pretty clear, right? In C#1, we've always had these notion of delegates, which I think is a far better approach than to using listeners. That's what listeners in Java, right? You had to attach to the listener, and then the listener would, it's a good pattern to know, but it was kind of verbose and kind of wasteful. So then they said, you know what? This is actually better if we do it like that. That happened kind of fast. So let me go back. Notice that this thing now in C#3 can become a Lambda expression. Now, I'll do it one more time because it feels like I'm doing it cheating. I'm not cheating. This is CodeRush. You guys probably use something like CodeRush or ReSharper. CodeRush is better.
Sorry. Isn't there also Just Code now?
What's that?
Just Code?
Yeah, I'm being recorded, aren't I?
Fine. You don't like just code. Very well.
Do you want an honest comparison? We'll do it after the show. Because,
Very well.
I'll tell you, just as a little side note, one thing that no other tool does, this thing will look at all your code and find any duplicates and merge them for you. Do you ever copy and paste a code that did the same thing? CodeRush will find it and it will fix it for you. Even if it's not exactly the same. Because we do a semantic analysis of the tree.
So you'll notice when identifiers are different, but it's the same code.
Absolutely. It's not a regex. It's a literal tree search. And we did it before Roslyn. How's that for cool? Right? Because you know Roslyn, it does that. But we did it before then. We have a whole parse tree, and if it looks fairly similar, you can set granularities and everything. No one else can do that. So anyways, I digress. So this is a way of declaring it faster using lambda expressions. And I think lambda expressions are really cool because you have this thing, S, which is the parameter coming in, and then you have a console.writeLine, which is doing something. Notice console.writeLine returns void, I think. Yeah, returns a void, and so that matches, right, an action, which takes something and returns a void.
Also, the type of S is implicitly determined.
That's right. And
unlike the delegate where it was explicit.
That's right. So how does it know that S is a string?
Because you're assigning it to an action of string.
Because of this, right? It knows. So this is all a strongly typed. Now, a word of warning. What does the var keyword do? By the way, vars don't work with delegates. I just want to point that out here. This is why it's being like, hey, I can't do that. But what does a var do? For those of you that programmed in VB6, which was the last ugliest, horrible language Microsoft put out, there was a thing called a variant. Remember that thing? What did the variant do? Do you remember?
Anything have a connection type, I think, depending on what was assigned to it.
Yeah, that's what we thought. It actually saved enough space and memory for the biggest thing you could put in it. Right? That's not what the var keyword does in C#3. The var keyword does implicit typing, right? Which means it looks at the right and tries to guess on the left. It just cannot do that. So for example, when I say var I equals 1, this thing is going to be an int. If I say var equals 1m, this thing is going to be a decimal, right? If I say 1d, it's going to say a double because it knows. The thing over there is a double, so I know. So it's not like saying, I don't know what it's going to be, so I'm just going to put an acre of land out there, for you to put whatever you want. Instead, it really does type it. But that does not work with these things. I don't know why. There's probably a good reason, but I haven't asked yet. Action of string. Okay, so now we can go ahead and we can call A. We can say Seth. We'll say
Would
sir.
it work with an anonymous delegate? Or you're just saying it doesn't work with delegates at all?
Doesn't work with delegates though. I don't think it works with anonymous delegates either. So let me see if I can put it back.
Yeah, it was an anonymous delegate before.
Yeah, but it was an anonymous delegate, but anonymous implicit typing. That's what
It should work with that, actually. No?
Because you cannot assign anonymous method implicitly type a variable. I think it has to do with something about the way the compiler allocates the space for the thing, right? Because there's a thing we're going to talk about next called the closures. You need to be careful about, right? Because the A will lose scope at the end of the function, but the variables that it closes over might not be out of scope.
And that's something that's easy to run into when you're doing parallel.forEach inside of a for loop.
And that's a different problem because parallel for each.
When you're capturing the for loop variable, problem.
Mm-hmm. All right, so when I do this and hit F5, we should see I don't know why I have this.
Zoomed in way a lot.
F5. There it is. Search. Good. Is my zooming in helping? I always think it helps.
Yeah.
Okay, good.
It'll help the people watching on YouTube.
Oh, good, excellent, wonderful. So there is that. Well, what about the functions where we want to return something? Well, that has to do with that is the func, right? You have the thing that comes out. So, for example, if we have something that returns a string, we're going to say this, and then we're going to say Bob. Why is a compiler complaining, by the way? It's already using this symbol, right? So that's the problem. So you'll see right here that S cannot be changed, so I'll give it F, and it should be okay. Right, so there's the thing. And so when I say F, what is it doing? Well, it's returning a string. So I can say CW of F. Oops, too many brackets. And this can go away. Right, because now this thing F is returning nothing. Oh, I'm sorry, it's returning a string but taking a nothing. I got that backwards. So the thing about how these things work is you can give it another type. But notice that now, instead, you have the things that go in, and the last thing is the thing that comes out. We can talk about covariance and contravariance, but it gives me a headache, you know. Covariance and contravariance, the thing that it's saying here down here, is about what you expect to happen, right? Remember when a long time ago, when you needed an object to pass, you did a func of t and it had a certain object, but then you passed in a descendant and it got mad? It's not going to get mad anymore. That's what covariance and contravariance is for. So there is this thing. When it says f of string, that means you pass in a string. So you say s, and then you can say s. Oh, I can't do s again. Or can I? Oh, yeah. Yes. You can do that in that case, right? So s goes to, I like the equals, I like to say goes to, right? The Anders operator, as Hanselman likes to call it. You have s plus Bob. And so now when you call console.writeLine f of Seth, you should have Seth and Bob. Yeah. Oh, did I do that too fast? So there it is. Okay. So that's what's going on there. And again, you can model any function that takes in up to the magic number 16 things, and then spits out one. So that's what those func things are. Any questions? So again, as you probably know, you can add these things, right? You can say action of string v equals a plus 2, right? Notice, again, to remind you, A is this thing we declare with a lambda expression anonymously using lambda expressions, and 2 is this thing over here. We can add that, or we can say A plus 2 plus 3. I'm sorry, it was 1. 1, which is another function.
Plus A.
Plus A, yeah, because we can. So now we can add these things together, and everything is kosher. And when I execute V of Jim, then you'll see that all sorts of cool things happen. Right, it's just everything is being executed. And so now functions become this thing that we can pass around. We can play with, we can do stuff with. But then there's this interesting notion of, well, what happens when I do crazy things? So here is an action. So let me delete all this stuff and start again because we can't. And let's go to this function again. We're going to make an action of string, right? And this is going to be an A goes to A equals S goes to console.writeLine inline plus S, right? So this is what we had before. Now I'm going to do this. Yes, sir.
Not to derail your current thought, but it's also notable that your action of string can be assigned to do something and vice versa.
Yeah, we just did that.
Okay.
Yeah, in fact, remember when we added all these things together?
Right.
Those were do something types. I could have declared to do something. That's right, of X to do. Yeah, absolutely. Well put. So we're going to put D equals Jim. Okay. So we're gonna inline. We're gonna do this. No, I have to put it up here. So we're gonna put Jim up here, but then we're gonna do something crazy. Right. Console.writeLine. Let me use the string format, and let me also put in parentheses here 1. And we're gonna put the here. Everyone knows what string format does? Just for those of you that don't know, string.format, what it's doing is it's saying print this thing out, and where the 0 is, put the first thing. Where the 1 is, put the second. That's what that's doing. So now I'm gonna execute A and pass in I don't know, Doug. I need to use lady's name, Sally. There you go. So what does this do? Here, I'll move this down so we can see it all at once. What is this going to do?
Going to print out inline Sally Jim.
Inline
Sally Jim.
That's right. So let's take a look at that. Great. So now let's be crazy and let's just say D equals I don't know, Susan. Now let's call A of Sally again. Uh-oh. What's going to happen? Then the janitor's going to have to come and clean up the mess, right? Your head. Well, there's one of two things that can happen. What are they?
It'll change. It'll not change. I guess there's a third one. It'll explode.
Oh, you're right. That's like the remember that super checkbox that came out in the mid-90s that was like checked, unchecked, and we're not really sure. Remember that checkbox, the special one? Yeah, so there's really 3 options, right? It could say the same thing. It could say a different thing. Or it could just not. What do you guys think it's going to do? I'll tell you what the right functional thing to do is. Functionally, real functional programming languages have this thing called immutability over captured variables. Right? So what happens is when this variable is captured, it's called a closure over D, by the way. When the function closes over the variable D, it closes over the value. And that value does not change so that this function, right, has no side effects. That's the special functional way of doing it. Right? F#, I think, does it that way, if I remember right. I don't, to be honest with you. Haskell will definitely do it that way. OCaml will do it that way. Because what happens is, in functional languages, they're of the opinion that if a function does something, it should always do something the same way. Kind of like the function f of x plus 1. Right? If you put in 2, it's always going to give you 3, and the universe is still going to remain the same. Right? Regardless of what's happening. But here, let's just see what happens. How many votes for it does the right thing?
Right thing being staying the same.
Yeah, being staying the same. No, everyone's like, no, man, no. Because our brains as C# folks, when we look at this, is we think it's changed, it needs to change. And that's what it does. And I think they all, I can imagine the meeting, right, where they all sat around and are like, no, it needs to close over the value. What is it closing over here, by the way? Is it close? Remember there's these 2 pesky things that we learned in computer science all the way at the beginning that the teacher tried to hammer on us, passing by, or by, right? We always get confused. I don't know why we do. But it can either close over the value or close over the reference, which is the address of the mailbox and what's in the mailbox. If you switch out what's in the mailbox, you're going to get a different thing versus you actually have a piece of mail. And so here, this is closing over the reference. That's right. And you need to be very careful with that, right? Because like he said, in the parallel for example, if you have things mutating inside of your parallelized for loop, you're going to cause contention with the other threads. Because parallel for, in essence, spawns threads for each go-around. maximal allowable threads, obviously. And I use parallel for a lot in some of the machine learning stuff I do, take advantage of multiple cores, especially in things that don't change. But if you are changing values that are being closed over by reference functions, you're going to hose yourself. So you need to be careful. This is something we need to remember, that this is the way it happens.
If D was an int.
Huh?
If D was an int.
And notice that we...
Change it to value type.
Let's take a look, dude. How many say that it actually changes? Do you still say it changes? Anyone else say it does not change? Oh,
Still change.
yes. That's very, and it's important to know this, right? Because you're going to be like, I'm going to go use some functions right now, and all of a sudden you're going to close over variables by reference, and then there's going to be some weird things happening, right? Especially if that's a static variable that's being changed outside of your purview, then these functions are going to start to get really weird. And so just a thing to remember about closures. Capturing data captures it by reference. Okay, any questions about that?
Even if the value type.
Excuse me.
Yes, sir.
I'm a bit confused. What is such a big deal about it? You are invoking this function, and you are saying whatever is this value, you just spit it out.
Yes.
So at this point, this was the value.
Yes.
So it's turned out to have 5.
Yes.
And at this point, this was the value, the latest value.
Yes.
So what is the big deal about it?
Here's the big deal. Let me do something here real quick. So I'm going to widen the scope, make it a field, and not only that, I'm going to encapsulate it with this thing right here. Very good. Very good. Very good. So now it's this thing, and you know what? We don't even care. So we don't even need to have backing store. Well, I'll just leave it like that. So now we have this. Okay. So D equals 5, right? So we have D equals 5. Very good. D equals 6. Now, here's the thing. Let's say this computation is fairly important. This delegate is fairly complex. And you've captured over a member of the actual class that's writable outside of the thing. Right? Now, all of a sudden, because this stuff is coming in from the outside, there's a change that's going to happen to that reference. And it's going to do something different than what you might expect. So, while I'm saying it does close over the reference, and I'm saying you need to know about this, I'm not saying it's evil. I'm saying it's not the preferred functional way of doing it, but I understand why it was done this way in C#. Because, like you, this is how I would think if I'm an inherited programmer. But what I am warning is that you need to be aware that that is indeed what it's doing. Because, for example, especially in for loops, if something gets changed from the outside, or you do message passing, or some other things are happening, you need to be aware that that might be somewhere to look if you close over it. Is it bad? I don't know. I'm indifferent, to be honest. But it is something to be aware of. If you're doing funcs like that, then be aware that that's going to change what's going on. Does that make sense? So yeah. Does that make sense? It's just a be aware. There's no value judgment. Actually, there is a value judgment because it's passed by reference. It's not passed by. All right, I'll move on. All right, so we've gone through. What time is it? Oh, good. I have like what, 20 more minutes? What time do you guys want to go? I have a couple more things.
We can stay till 9, but we have prizes to give away.
Okay, good. I'll skip the anonymous type. No, I think I'll do anonymous types. Is that okay?
Be my guest.
Okay, so you guys have probably noticed that there are some times where you are writing code. Oh, should I take a break? You guys want to take like a 5-minute break? We're good. Okay. I worry because I get involved and I forget that there's this thing called time. All right, so every once in a while we deal with multi-valued things, right? And we end up having to write this class and do this one thing, and it just sucks. So there is a way to actually do that. without having to do that. So I can say var A equals new, 1 equals 1. Sorry. What should we call? Let's do something. Name equals Seth. A birth, a date equals date time dot now dot end days. This means I was born yesterday. And there we go.
What
So-
do you take me for?
Huh?
What do you take me for?
I know, I was born yesterday. So notice we have this thing called an A. Notice we're making a new nothing, right? But this nothing has properties, right? So I can say A.name, and it knows about it, right? This is the cool thing, right? It knows that it has a name, knows that it has a birthday. And the thing about it is these things are called anonymous types. Here's the cool thing about anonymous types, right? If I say A.name equals Joe, it's going to say, yeah, I don't think so.
Unless you're in VB.
That's why we don't use VB. But imagine, oh, it does let you change them?
Yes.
Why did they do that?
I don't know.
So these things, notice they have a special type. And when I hover over it, it's an anonymous type of tick A. This notation is borrowed directly from OCaml, which is borrowed directly in F#, which means that this is a thing. It's a thing, but it's a statically typed thing. So because it's statically typed, we know about it. So for example, I can say, oh, here, let me do a var list of things equals new. I can do stuff like that. This is called inline declaration of anonymous types. So now this var is an array of things, right? But it knows about it. It knows about the type. But here's the thing. This anonymous type can only exist inside of this method. There's no way to pass it out without this. And the reason why, the question is, why would you make these? And does anyone have a good reason for using these? Everyone's like, yeah, well, we use them all the time. When we're using link, for example, doing projections, these things can be projected onto these anonymous types as intermediaries to get to your final object graph.
Yeah, but it's a bit awkward to then return the projection.
Not if you project it onto types.
Right, but then you're not using the anonymous type. You're projecting it onto a real type.
You'll see in a second when we do yields that it might be. It very well might be in some of the intermediate steps.
Okay.
You know what I'm saying?
Yeah.
And so that's a really good comment, which leads us directly into. Now, the reason why I show you all these things is because each one of these things that we keep at Lambda expressions and anonymous types and closures, all these things start to become important when we look at link, which is a syntactic sugar placed over a couple of things that we're going to look at in a second. Okay, so this is an anonymous type. And it is indeed immutable in C#. I guess in VB it's not, which is, I think, a bad thing.
Agreed.
Okay, so the reason why I bring this up is because immutability is a fundamental concept of functional programming. Now, while you cannot necessarily eliminate mutability, for example, when you print something to a screen it mutates, there are languages deal with it a little differently. Haskell, for example, uses monads. F# just doesn't care, right? It just does. F# is like a hybrid of a functional and not. So you can say let mutable x equal, which means that x is mutable. But this is just one of those things of functional languages that I think are really cool. I don't think you can pass these things around. I just haven't tried. If you do find a way to, let me know. Look it up. Okay, so next thing we're going to do is we're going to talk about lazy evaluation. Okay, so we want to, let's say we want to make a function that returns a list of integers, a list of even integers, right? So let's do the simple thing first. So we're going to static IEnumerable int get numbers. Okay, so we're going to say var x equals new, and then we're going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We can do that, and we can say return x. And then here I can look at this function, for example, get numbers, and I can say for each of these things in get numbers, write it. Okay. So is that, I think I did 9, 10. That was too much. So let me do that. Looks like we're okay with that, and I can get rid of this. Okay, so what is this going to do? Well, I mean, I don't even know I ran it. Everyone knows what this is going to do. Right? So 1 through 10. Okay, so you write this function and returns 1 through 10, and you're like, okay, now I want it to return 1 through 11. So the stupid thing would be to go in here and say, hey, let's return 11. What if you want a function that returns all integers? This is where it's kind of interesting, because there is this thing which is really cool, and it's here. I'll show you. While true, right? I told you you're not supposed to write code like this, right? And here's where the cool thing happens. Oh, I totally messed up my delivery by not putting the 1 there. And now, the compiler is okay with this. And you're like, wait, what? Now I have to put a brace in here. Okay, now I want you to look at this, because this looks really weird. Okay, have you guys seen this before? Okay, everyone's seen this? Okay, so sometimes you're like, wow, that's so cool. So you guys are like, yeah, dude, seriously, you could have done it without that. All right, so what does this do? Maybe you haven't seen how it actually reacts, though. So let's do F5. Let's do F11. Notice how it's going to jump, right? So we're going to go to in. When it goes to the end and say, hey, I need the minus the next one. So it's going to go that. It's going to pull it. It's going to put it there. And then it's going to check. And then it's going to go back to this. Notice where it started off from. And this is something maybe that I didn't. So it's going to put this out. And now when it goes back to the end, notice where it ends up. It ends up here. Because when it yields to the execution to this. These are called coroutines. Because they're working together. This one's passing the ball over here. This one's grabbing the ball. It's putting it out on the console. It's going back and saying your turn. So it's like a ping pong match. What if we only want to get the even numbers? Well, we just pass any func of int bool, and let's call it the predicate. And I can say if predicate of I. Boom. That's pretty cool, huh? Oh, except for I'm an idiot.
Would it ever return? Because I doesn't change if the predicate returns.
What's that?
The I doesn't change if the predicate returns.
Are you sure?
Well, I guess we're going to find out.
I mod 2 equals 0. All right, don't be angry with me, compiler. Okay. Okay, so this is we're okay with, right? This takes an int and returns a bool, right? And this takes a function called the predicate, which takes an int, returns a bool. So I can say if predicate of I. By the way, this plus plus operator, what is this? What does this do?
Pre-increment.
It's a pre-increment. Is it pre-incrementing by value, or is it pre-incrementing the box that it's in? It's the thing inside that's incremented.
Yes.
Okay, so then that should answer your question. You know what? I'm going to do something even crazier just to show you how the thing will jump around. So let me introduce it as a local, and we'll call it our P predicate.
Are you gonna put a print statement in our predicate?
Huh? What'd I do? Huh?
Are you gonna put a print statement in our predicate?
No. I'm just going to let the compiler do its wonkiness. Okay, so now, remember how it like jumped up and it passed the ball around? Now there's 3 friends to play with. All right, so I'm going to hit F11, get number P. It's going to go in there. I'm going to say while true. Watch this. Boom. Right now it's playing with friend number 3, right? Hey, you get the ball too, right? So this is what I'm telling you. Intermediate steps might be doing anonymous method return.
Okay.
Anonymous type return. That's what I'm saying. So now it's going back up there and saying, you know what? Nope, you're not. You don't pass. Now we go into here. We do it again. It does. Uh-oh. Is it ever returning? Why is it not? Oh, why is it not incrementing? Because I didn't start it at an even number. You were right, my friend. Let me start it at 0. And now it should work.
No.
Let's give it a try. By the way, is this going to return? This is true, right?
Yeah.
So the spot in the memory. Oh yeah, I have to increment it. You're right. Good call. Why do I have to increment it?
Because we're gonna call it again.
That's right. Thank you for that. I thought it would work. So I'm going to say plus plus I here, and then I'm going to say yield return I. And this is going to put to -1. Good call, my friend. Good call. All right, so we'll F11 this. We'll go while true. We increment it, then we test. Yep. We go to this guy right here. Break if it's greater than 11. We're not going to break. We're going to go to the next one. Notice though, the cool thing about this is it's obviously anyone can make a logic error. I made a logic error. Thank goodness you guys are all fix it. But please remember that when you do yield, when it goes back, when it gets the ball back in its court, it's going to start off right where it left off. Right? And you see that. You see that right there. So while true, plus plus I, predicate no, plus plus I, predicate yes, and there we go. 0 through 12. Okay. So let's be clever, and let's write an infinite Fibonacci sequence. Okay, so you guys know what the Fibonacci sequence is? The first one is going to be a 1 or a 0. I mean, it depends on your base case. Second number is going to be 2. Third number is going to be the sum of the previous 2. Right? So the easy thing is to say yield, return, turn 1, yield, return 2, and now we get into the coolness, right? Because remember, this is okay, because it's going to yield, and then it's going to come right back here. But now we need to do something about adding the last 2 values. How do we do it?
Remember what they were.
Yes.
Declare some local variables to keep the previous number and the prior number and the one before that.
So is this enough variables?
Yeah.
Okay. What do we do?
Yield return A plus B.
Then?
A.
Equals B, or
Yeah, A. Huh. We might need a
or
10.
B equals A, that's there you go, C.
Okay.
And then A equals B and B equals C. That should do it. Is that still called get numbers? No, it's called fib.
We'll take the block off and see if it works. Yes. Wait.
1, 1, 1, 2, 3, 5, 8. Yeah, that's it.
That's pretty cool, right? And so notice what we've done is we've done a clever way of this. This is a cool way of. So the reason it's called lazy evaluation, right, is because it will only evaluate when it needs to. So imagine that this operation A plus B is completely expensive, very expensive, but you want to be able to enumerate as many as you want. Notice that when this method is called, it goes into the for each loop, and it's only pulling each of the values as it needs it. But when it hits the breakpoint, it skips out of the for each loop, and what happens to the evaluation of the list? It stops. And while similar to what link does, because link, when you're passing an iQueryable around, that thing is not a list. It's a promise of a list. These lists are not materialized until you call to array or to list or whatever. Or you expand on the enumerable with a for each call. You know what I'm saying? And so these things are promises that they're going to. I better not use the word promise because the word promise is used in JavaScript and WinRT for callback. Well, I guess what's called callbacks. So that's the cool thing about those things right there. All right, any questions about that? Okay, so I have about 2 minutes. Let me talk briefly about extension methods. Extension methods allow you to add methods to existing objects, more or less. It's kind of like a decorator type pattern, more or less, that you can use. And the reason why those are important is because IEnumerable all of a sudden has all these cool extension methods. So for example, I can say fib dot, oops, not lock, dot, and there's these as enumerable, as queryable, contains, default, because there's tons of extension methods built on top of the IEnumerable thing. You can see that right there. And so, for example, you could say fib dot where, and then pass in a functional predicate. Something like P, right? And I can say var q equals fib. Oh, really? Let's try it. Oh, looks like it finished. Why is that possible?
Because it didn't evaluate fib.
Because it did not materialize the list. It didn't need it. It never materialized it. Now, if I were to say something like this, if I were to say for item in a queue, now it's hung. Why? This is where we need to be careful. Remember how I had that other careful thing? Why is this hung? Now, remember, we're assuming something about the IEnumerable that we shouldn't be assuming. We're assuming it's hung. Right? You'll see my processor spinning up. It's adding Fibonacci. It's probably overflowed by now, so it's negative. We're assuming that this where clause of the IEnumerable, as it pulls each one, knows that these values are ascending. The where clause doesn't know, so it's going to keep looking until, right, because the list goes on forever. But this thing, this where clause, is evaluating on every piece of the list because it's not assuming that they're ordered, right? And it's thinking there's going to be another one, and so this will hang. It's getting there. Now again, it's not materializing the whole list, but it keeps on fetching the next one, fetching the next one, fetching the next one, fetching the next one. And it looks like the next ones aren't fitting. But there might be one in the future that is less than whatever the number that is that, right? And so that's what's happening. It's trying to find the next one. And so that's where you gotta be careful again. With these things, you should never use a wild true, because it just feels like it would be bad. Oh, it actually did work in that particular case. But you got to be careful as it's pulling them. It's not going to assume anything about the list. Okay. All right. Any questions? That's it. And then finally, the thing that we can do is we can say var s equals from t in fib where t is less than 10,000. Right. Select t plus 1. T plus 1. Oh, I know why it's math because of that. There you go. So now you can do that.
And then we could for each through.
Oh, by the way, this is why it broke last time. By the way, and so when I notice that it's going to keep going forever. That's what I said that, but it didn't happen. That's because I had a break statement there. But now this is going on forever, but it's putting all the odd ones in there. So that's why.
You know, even ones.
Yeah, even. Yeah, thank you. So now we can say S, and this. Well, this is going to go on forever, right? Again. But notice that what we've seen is that this fib dot where dot select, right? This func int, these two things are exactly the same thing, right? Except that this is syntactic sugar over this thing right here. It's exactly the same thing. And so that's where link comes from. Now, the link is evaluated differently when you're doing link to SQL, for example. It's actually, it has to pull the whole list when it materializes, and so you got to be careful about select n+1 problems, right? Because it's lazily evaluating. So if you're doing a select with a subselect in the link query, it's going to only pull them as it needs it. So you got to be careful about how you materialize things, because you might be selecting all of the items first from the outer list, and then for each one, it's going to do a select statement for each. So that's a problem with link. You got to be aware of because of lazy evaluation. All right, any questions about this? Okay, so that's all that I have then to leave some time for the raffles and stuff. Any questions or comments? This is pretty much stuff you've already done, right? Hopefully it filled in some corners where you're like, yeah, I can see now how I could change the way I write code. Like, by the way, this has completely changed the way I write code. Just to give you one example, let me close this down. Because running 2 Visual Studios, man, that's like, let's see what's going on. Look, it's still trying to get rid of its memory. Jeez, it's such a pig. All right, so did I open the other dev env? Okay, here's the other one. I'm going to show you a library I've been building, a numerical package for doing machine learning. I'll show you how this kind of thinking has influenced the way I write code, briefly. And any questions, by the way, or comments as this is loading up?
How did you get to be so awesome?
Oh, thank you. My wife, really. She's really looking, and so like I look at her and like my awesomeness gets to be better. No, the thing about these things, again, is the only reason why I understood them is because I actually fooled around with them in my functional programming class, and it was because of F#. So let me load up something here.
The Fibonacci sequence is actually kind of hard to work with because you can't really.
That's right. You got to be careful.
You can't do much of any kind of queries without.
Unless you pass it unless you pass in a function explicitly to break the while loop, right? Because in the while true, you could do if pred, right? So you can do an until predicate, for example, and that predicate would be a func of int bool until, and that until function would say when it reaches truth, break.
Okay.
Does that make sense? So here's a matrix. You guys know the matrix, right? By the way, you can download this code. It's for free, so you can get it anywhere. Take a look at the way now. So we're going to go to some crazy things that I did that I thought were just the coolest thing. Oh, here, for example. If I want to get the rows of a matrix, it's going to return a vector, right? So instead of me saying, okay, let me just return the array, I'm only going to return them as needed. All right, so you see that influence there. Now let's go to this. Have you guys ever seen the this thing? So if you ever want to make an object of yours index accessible, you do this and int I. But there's no reason why we can't do something like this. What does this do? That's cool, right? This says give me the double, right? Oh no, this is a set function. Oh, this is even crazier. This is a set function. Notice there is, now I got the matter. Set, what does that mean? That means we're going to set a value, right? So when I say matrix and then I put a function in there equals 5, what is that doing? So it's going to go through each thing, and where it evaluates to true, it's going to set the value. So for example, I can say matrix M. Well, let me just write it, because now you guys are all like, what the freak are you talking about? Here, we'll put a little breakpoint here so we can get a good feeling for it. And let's go to this symbol here. I'll just pick any random, if that's okay. So we go to view code. So we have grouping, display, cursor, feed data. No, dang it! I need to find a matrix. Oh, I know where I can get a matrix. Sample. Okay, so here's a matrix X, right? I can say X, where, right? Notice I have all sorts of crazy ways of, dang it. Do I have to hit the stupid arrow? There we go. I can pass in a func that returns a bool and double. So I can say this, D equals -1 equals 0.
What does that overload return again?
Doesn't return anything. It's a set.
Oh, yeah.
It's a set. Right? So what does this do?
So matrix find everything where the value is equal to -1 and set the value to 0.
Boom. That's easy stuff, right? That makes sense, right? Notice that this came directly from functional thinking. So for example, if you want to go to a matrix and set all the irrational values to something that's rational, you can say XD and then whatever predicate you want and then set. There is no get. It's only set.
Can you say one more time? What does it do?
Oh, good question. So there's a board right there, right? Do we have a... So imagine you have a matrix like this. Right? You have 1, 2, 3, 1, 2, 3, -1, 0, 1. This matrix right here. But you want it uniformly. Say this matrix is a lot larger, but this is our example. Say you want to make sure there's all non-negative values in this matrix. Instead of saying for int I equals 0 for the rows, for int j equals 0 for the columns, if ij equals -1, then ij equals 0, you can just do that in one call and say set all of the values that are like this to 0. And so it's going to do this evaluation for you. That make sense? Now, again, I will admit, and I will be the first to admit, that this is probably, you probably won't be doing this, maybe, I don't know. Hopefully you will. You can download the library if you like. But notice that this, to me, seems more concise. Right? And it hides away just the stupidity of having to do with matrices, you have to do so many for loops. I'm not kidding. I was getting tired of it. So I just did this. And so there's a tendency to simplify code in that way. And then there's other ways, but I think that's one of the better examples. All right, I'll stop yapping. Any questions or comments?
Within the index, it will still be looping, right?
What's that?
Within the index, it will still be looping.
Yeah, it still loops it inside there. So see, it does the loop here anyway. But I don't have to do it every time. Right? Now that you see it, then now it makes sense. Okay. All you.
Yeah,
There you go. Anybody have any remaining questions for Seth? Anything you want him to go back here? Please pick a book.
Here it is, if you want to see.
Oh, cool. There we go.
Notice that
That's fast.
the assumption on the bottom left-hand corner is that the portfolio only has one of each share of the items in the grid above.
Okay.
And then this is the stock price of the one that's currently selected. So if I wanted to go to this one right here, right, it would do this right there, right? And then you can see the open, low, high. But notice this is sub-second, right? This is sub-second, WPF on top of that, right? And I built this in an hour in front of Commerce Bank developers so they can see how it's done. Right? So this did not take a while. And notice that the stock prices look sort of stock-ish because I'm using a geometric Brownian motion with a constant rate of return with a certain value of drift, a certain value and a certain volatility value. So that's how that's happening automatically. So those are, it looks like stock numbers, but they're not because I'm pretending to be stock. Doesn't that look cool? I can just stare at like random motion. There you go. And it's like it has a life of its own.
It does. Very good. Day in the life of the market. Okay. 114. All right. There we go. Thank you, Seth, for this demo. It's fun to see the donut chart being used for once.
Thank you. Yeah, I did that on purpose.
One, I've never seen it used quite that way.
Oh, whoops, I didn't do it on purpose.
126, there we go. And 121.
Don't know if there's anything left over there.
Oh, I don't think so. Oh, we're out of books. I have 2 more. I have 2 more. And there's bags in here if anyone needs a bag to carry their stuff home in.
3 more books.
I don't know. This might not be so popular, but I don't know if anyone's doing SharePoint. 123.
Yeah, it's me.
Okay. And next is 115. All righty. My guess. And 118.
There you go.
And I don't know if I have a book. You didn't win anything this time? Unbelievable.
There's
You always win.
different books there.
And I think that's it. Nope, we're out of books.
A coffee cup.
What are we at? 124?
You want a mug?
Pizzas.
I think they're going to freeze the pizza.
What's that?
I think they're going to
You
freeze
need
it.
a mug?
Wait, did someone not win something?
Yes,
Who didn't win something?
this guy right
Do
here.
you have Code Rush?
Our intern.
Oh, it looks like you just won a copy of Code Rush.
Awesome.
Boom!
There
Give
you
me
go.
your card. I'll send you.
He doesn't
License.
have a card, but I do.
Okay.
That's my personal.
I will get you a license to Code Rush. Did you see how I did like coding really fast? And that's how I use Code Rush.
When you hit like one keystroke,
And it went.
it'll- yeah.
Remember when I went between delegate, lambda, delegate, 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 delegate.